Hi, I'm Steve Parlee with Moose Logic, and today we are here to have a short discussion about storage repository design, also known as LUNs in the IT industry. We're going to discuss why storage repository design is important. We're going to discuss snapshots and the implications that storage design has on snapshots. We're going to discuss disk usage, how storage repositories impact your disk usage, and we're going to talk about performance a little bit, again, disk and cache. So first thing is, why is this important to me? Well, it's important for all these reasons I've listed here. It impacts your snapshot design, it impacts how granular you can be with your back-end SAN snapshots, it impacts the underlying disk usage, the disk usage performance, and what you're able to do with write cache if your SAN uses memory-based write cache. So let's start with snapshot implications. And the first thing we're going to talk about is there are two basic theories on storage repository design. One is you create a large storage repository and you start dropping your virtual machines into that storage repository. Now, well, this is great. Number one, you should never put more than about 5 virtual machines into a storage repository, because at that point, disk I/O starts to get heavy and you're going to suffer performance. This is simple. However, you lose a lot of control and granularity with this model. For example, if you want to use a SAN-based snapshot, you're going to have to snapshot this whole storage repository. And what that means is you've just snapshotted all your virtual machines within that storage repository. If you want to roll back just this one VDI virtual disk for this one virtual machine, you can't do that. You don't have enough granularity. You roll back the whole storage repository, and you've rolled back everything within that storage repository. So that's a trade-off. Simple versus granularity. Moose Logic generally likes to recommend that each virtual machine, virtual disk, goes into its own storage repository. So in this case, the operating system for one virtual machine would be in this storage repository, and the data may be in this storage repository. What that allows us to do is, on the back end, if we're going to take a snapshot, we may only want to snapshot this one disk. This disk here, we're relying on backups. It might be a SQL server, and what we would be doing then is taking 15-minute backups, writing them out somewhere else, relying upon those as your disaster recovery point. If you needed to restore your operating system for some reason, you applied a patch or broke it, you can simply roll back that one snapshot. So it gives you extreme usage, extremely granular control over what you're doing with your snapshots. The other thing about snapshots is there are two ways to do snapshots. I just covered backend, but VMware, Hyper-V, and Zen Server, Citrix Zen Server, all have snapshot capabilities within their product. And the way those work is when you go to snapshot a disk, a virtual disk, it creates a Delta file. And it creates that within the storage repository. Now, if you created this storage repository the exact same size as your virtual disk, you have no space remaining. So if you're going to use those kind of snapshots, you actually need to make your storage repository double the size of the virtual disk. That way, when you save a snapshot, it can actually create another virtual disk into which the deltas are written. This is great. This is a good way to do snapshots. It allows for quick, easy rollback. If you need something rolled back for like a development environment, great. That works excellent. There is one shortcoming to this, and that is this type of snapshot, because it is a delta disk, relies upon the original disk. If you lose this disk for some reason, it corrupts or what have you, your snapshots are of no value. You can't roll them back. You've lost your original disk. If you're using back-end SAN snapshots, which again, you can use both of these if you design it right. If you use back-end SAN snapshots, this snapshot of this virtual disk stands alone. And you can go back to your, if you've lost this disk for some reason, you can go back to your back-end storage and restore it. So you've got your granularity, you've got your different types of snapshots, and how these are impacted by your disk storage. Also, we should consider that, again, over here, if you want to use program snapshots, you need to have extra space for your storage repository. And again, it's a one-to-one and it relies upon the original disk to roll back that snapshot. So this is another way of handling snapshots. You'll see a lot of people do this one large storage repository and write their snapshots in there. Good solution, not quite as efficient. Another thing about laying out your LUNs in this manner is your physical underlying disks and the performance you're going to get out of those disks for this reason. If you have a storage repository like this, you might have a series of disks underlying here in an array, so you're getting pretty good performance. All these virtual machines are hitting this same series of disks. You can't say that this virtual machine here only hits these 2 disks, for example, for their I/O. It's not possible. All these machines are going to all these spindles, 1 I/O. With this model, you can actually set up each individual type of VM to run within its specific set of disks. So let's say this is an operating system as well. Let's say we lay out 3 disks. For operating system, you might have these disks tied here as well as here. So these storage repositories are created on these disks. But for performance, again, let's say this is SQL and we need that data to be on a high I/O. What we can do here is we can create a separate set of disks and specifically assign them to this one storage repository in line. This is one VM working together. However, we now have the storage repository separated out, and that gives us better performance. Another thing that's important here is the reason why it's good to use different LUNs is a lot of SANs will allocate cache. They allocate a certain amount of cache to each individual storage repository. So if you had cache here, this one gets some cache, this one gets some cache, this one gets some cache. And what that is that's write cache. So before the system has enough time to actually put those writes down to the disks, it has a little bit of write cache that each machine has to utilize. And it's not relying on another virtual machine to release that cache so you can write into it. Whereas with this model, you'd have one cache to serve all of them. So that's the basics of why storage repository is important, why it is something that you should consider, and this is how Moose Logic likes to do it. My name is Steve Parlee with Moose Logic.